Hey guys, this is my presentation for Hadoop and Hive for the database class here at DSU. So let's get started. I'm using, for my installation of Hadoop and Hive, I am using Ubuntu 12.04. So let's see if I can actually figure out how to write. There we go. 12.04. And the latest stable versions of both Hadoop and Hive. And these both have some dependencies. For Hadoop, it is Java. For Hive, it is everything that Hadoop needs. So I'm going to say Hadoop. And there's plenty of tutorials on the internet on how to install Hadoop and how to install Hive. They're pretty simple. It mainly involves extracting a zip file on both and setting some paths in the configuration files for Hadoop and some paths in the bash rc file. So, anyways, for Hadoop, let's go over what Hadoop exactly is. So Hadoop is for big data, and I capitalized big so that way we can go more into it. So what is big data? Well, it generally means can't fit on one machine. Okay, so in the past this might have been, 600 megabytes. Now we're talking like 5 terabytes and bigger. So this big data thing's pretty new. Most people know about it. And it generally started with Google. And they needed a way to process through all these weblogs and HTML stuff and find all the links and reference them. So what they created was called GFS, and that's how their algorithms ran on. So this stands for the Google File System. And of course it is closed source and expensive to buy. So some smart people at Apache decided they were going to mimic this. Oh, one other thing about Google's GFS, it is formed on the algorithm called MapReduce, and we'll go on into this later, exactly what MapReduce is. But anyways, so it's some smart people at Apache come along, and they decide that they want to make something like Google, but they don't want to pay the money for it, so along comes Hadoop. And just like Google's GFS, Hadoop has its file system called the Hadoop Distributed File System, or HDFS. So let's write that down. And it's completely free. And it's written in Java. So all your MapReduce programs are written in Java. Makes it simple, makes it easy to learn for most developers. Alright, so how Hadoop works is that if I have many servers, call each of these little boxes a server. If I have a job, which I'm going to write over here, I'm going to give each server a little section, and I'll write which section they have inside. And so they'll all do a little piece. So I'll all get 3 outputs. So output 1, output 2, and output 3. And I'll get these 3 outputs, and they're all a piece of it. So For instance, if I said the final output, or output, boy, my mouse is acting up. Is equal to wow, it's really acting up. Is equal to output 1 plus output 2 plus, let's see if I can change writing. Alright, so my mouse is not working right. So I have output is equal to output 1 plus output 2 plus output 3. And so what that really looks like in the drawing, if we go up, is that these all get combined later on into my final output. And this is the basics of MapReduce. I want to take my job, I want to split it up, and then I want to combine the result at the end. Alright, so Hadoop has, we'll state this again, a few things. It has the HDFS, the mappers, the combiners, which we'll go over later, and reducers. So the important thing to note about all this is, first of all, the Hadoop file system is like any ordinary file system, except that it's across multiple machines. Now, if your data is really large, like say 5 terabytes or bigger, each will have a piece. So this will have 1 out of 3 of the file system. And these will each have 1/3 of the file system. And if we aggregate all these file systems together and load the list of files into one server, which we'll call the job tracker, so this will be my job tracker, we get basically our Hadoop distributed file system. Now, if we have more machines, we can duplicate the data so we can make it sort of like RAID. So Hadoop file system implements RAID in a general sense. It's not the hardware RAID, but it simulates it across hardware. Okay. Now, oh boy, I'm out of paper. The mappers work in the same way. So I have my job tracker, I'll call it JT, and then I have my 3 servers because I don't like to draw very many servers because it takes time. So I have each of my little servers, and my job tracker is going to say, hey, we have a job. So each of you servers, you're going to spawn some threads and do some job. So you're going to do 1/3 of the job, and each mapper is really a thread. And you split these among the computers, all these threads, and then they'll spit out some output depending on what you programmed in. So again, output 1, output 2, output 3. And this is all very good, but it's not quite done because I only have 1/3 of the output on each of them, and we have no way of combining them. So that's where the combiners come in and the reducers. So combiners, if I'm doing a word count, I might say, for example, my key value pair, so okay, so my key is the word, so 2, for instance, and my value will be the numeral 1. And I might have 1,000 of these. Okay, so on and so forth. What the combiner does is it sits here on the output here, and it coagulates all these different things of all these different keys that have different values, and it aggregates them on the same machine. So we'll get a slightly different output, and I'm going to slide over actually and draw this again. So we have our 1, 2, 3, and they all have 1/3 inside. And I get my output 1. I get my output 2. And my output 3. And then along comes the combiner, and I'll get O prime 1. O prime stands for output prime 1, and I'll get O prime 2 and O prime 3. But still, we still have the same problem. They're not networked together yet. So we'll come over here and we'll draw the reducer. And for example, in the word count program, the combiner and the reducer are exactly the same. So the reducer takes all the data from all across the servers. So the servers spread the intermediate results. So if I have my 3 servers over here again, and they're each going to handle 1/3 of the data again, just to make it simple. We're assuming they're all identical, all have the same processing speed. So the reducer, right before this, Hadoop will manually distribute the data all around. So we'll say O prime 1 has the keys 2 and the. And O prime 2 has the keys A and, just the way it works out. Random luck. And O3 has the words 4 and 2 again. So we have 1, 2, 3, 4, 5 words and 3 servers. So maybe this top one, this top little box right here, I'm going to color it blue actually. This one, maybe it will take 2 and 4. And then this one in here, which is pinkish, is going to take the and. Oh, oops, hold on, I forgot to circle this too. Alright, and this greenish one down here is going to take A. Now you can see that it's completely random on how they do it. So O1 is going to have to distribute its data across all 3 servers just to make sure we have a valid copy. And O2 is going to have to do the same thing. And same thing with O3. Now, then it runs the same program, and Hadoop, just because it's the way it's programmed, only gives one output because it's all networked together. So we get our output. And that's the basic way that it works. And because they're all threads, it's very easy to figure out. So then, the problem with Hadoop is that we have, can't spell either. So the problem with Hadoop is that we need programmers that know Java and Hadoop type programming. So they need to know Java and Hadoop. And there we went. Okay. So that's some pretty big problems, because not only do I have to have some programmers, they have to know Java, and they have to be familiar with Hadoop. Otherwise, I'm going to spend some time training them. So along comes Facebook, and they say, hey, we don't have a lot of programmers that know Java and Hadoop, and we have a big data, so they have big data. I think we all know that because they have a couple million people on, or a couple billion by now. So they have big data, and they are using a relational database. Well, as they got more and more popular, they had more and more need to not be using a relational database because they had big data. But all their code was built on a relational database, so they set about developing a SQL-like extension to Hadoop. And they wanted to keep the same syntax, basically, so they didn't have to train programmers, and they wanted to be able to handle big data. Alright, so they developed Hive. And just like SQL, it has some SQL expressions, which they called Hive query language. Or HQL. And that was their main contribution, and they released it, and it's, of course, completely free. And it's written in Java. So, now we have this Hive, and we can put things in a relational database, and it'll run on Hadoop, and everything's nice and dandy. So, I make a table, for instance, on Hive, and I can have some columns. So we'll call it A, B, C, and D. And then I get some rows. So there's some people. There's person 1, 2, 3, 4, and 5. But this is all a file. So it might be 1, comma, blank, 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 comma, blank, blank, blank. There's 4 columns, so blank, blank, blank. It might be a CSV file. Who knows what format it is. I chose to use the CSV because it's easy for me to actually look at when I was doing some testing. But you can store your big data as multiple files. So this might be file 1, and then I might have user 2 is in a separate file, so I don't run through my file limits. And now I can load it all into Hadoop, and I'll get my big table. So then, once I've created my table, however I want, I can select certain users from it using SQL-like commands. Not every SQL command is supported, but most of them are. And some people say it's slow. I didn't really find it to be that much slower than Hadoop. If I'm running through 5 terabytes of data and it takes me 8 hours versus 7, who really is going to know the difference? You're going to be at home sleeping, doing whatever. So then why is this useful? Because now instead of having programmers that know Java, I just need programmers that know relational databases. And as a bonus, I can have programmers that know Java, and I can have programmers that know Hadoop, because Hive runs on Hadoop. And this is one of the other strengths of Hive. Actually, let me write Hive strengths up here. Alright, so that's one of the strengths of Hive, is that not only can we get programmers that know relational databases, we can get programmers that know Java and Hadoop, because you can build extensions to Hive. So maybe your data is not perfectly formatted in a CSV format. Maybe there's a weird token right here, and there's another one right here, and you need to parse those out. So you'll build something in Hadoop to do all that, and then pass the results back on to Hive. Now the weakness of Hive, of course, is that it uses a relational database. Now, this isn't really a hindrance by itself, except that Hadoop, and therefore Hive, only do full table scans. So if I'm trying to find the first person in a table, I have to run through all the scans. So if I have a 5 terabyte file and it takes, we'll say, 8 hours to run through the whole table, well, now when I want to find the first person, it takes 8 hours. Compare that to Oracle, it only takes, what, 2 seconds maybe at that. But again, so we'll go back to the strengths now just to list this one. It's able to scale. And you can have it distributed. So instead of needing a 5 terabyte hard drive for this one scan, I might need 10 2 gigabyte, or let's see, I might need 2.5 terabyte hard drives. And because 2.5 terabytes hard drives are a lot cheaper than 5 terabytes, I might actually save some money. And that's the intro to Hadoop. Boy, come on, let me